Hi, it's Richard here, and in this episode we're going to look at resistance. So resistance is a measure of how difficult it is for current to flow through a component. And when charge flows in an electric circuit, the size of the current is affected by two things. First of all, the resistance. If resistance is increased, the current will decrease. And secondly, it's the potential difference. And if the potential difference is increased, the current will also increase. And resistance is measured in ohms, and the symbol for ohms is a capital omega. If you Google that, you'll be able to see what a capital omega looks like. So, some things to remember about electric current is that if it increases, the potential difference will increase, the number of ohms will decrease, and that's the same as saying the resistance will decrease. And there's two variables that affect the size of current. First of all, it's resistance, and secondly, potential difference. Now, there's an equation you need to know to calculate resistance, and that's resistance equals voltage divided by current. So we can calculate the potential difference, or voltage, using a voltmeter, and the current using an ammeter, and we can do that at the same time on the same circuit. Now, we can use the ammeter, as I said, to measure the current flowing through a component, and that's connected in series in a circuit. And we can measure the potential difference across a component using a voltmeter that's connected in parallel. Now, one thing you need to know about resistance is that the longer the wire is in the circuit, the higher the resistance will be. So just to recap that, to measure potential difference across a component, we'd use a voltmeter. And to measure resistance, you need, first of all, a voltmeter in parallel, you need an ammeter in series, and you need something called Ohm's law, which is R resistance equals V, potential difference, divided by I, the current. Now, we can plot something called a current voltage graph by varying the potential difference across a circuit component. The current voltage graph for a resistor basically has some features that you need to know about. So first of all, it's a straight line which obeys Ohm's law, which is the current equals the potential difference divided by the resistance. Now, the slope, or the rate of the graph, is equal to 1 divided by the resistance, and there's a constant slope, which means it's a straight line graph, and that tells us that resistance is constant. So to recap that, we can plot a current voltage graph by changing the potential difference across a circuit component and measuring the current. A constant slope tells us that the resistance is constant. And resistance is a measure of how difficult it is for current to flow through a component. And remember, the two things you need to measure the resistance of a component. We need to first of all measure the potential difference. And that's measured using a voltmeter in parallel. And we need to measure the current, which is measured using an ammeter in series. And when we've got a current voltage graph, there's the features you need to know is that the y-axis is current, the x-axis is potential difference, and the resistance is the line that goes through that. And the slope of that line is equal to 1 divided by the resistance. Now, on a current voltage graph for a resistor, the slope of the graph is equal to 1 divided by the resistance.